welcome to a new episode of the Water Talks podcast, where water stories, science, and application receive the focus they deserve. I'm your host, Els Vanbeckevoort. Today, I'm missing my co-host, Scott Barron, but I look forward to seeing him again soon. I'm also really happy to welcome Christel Broux back to the show. She's calling in actually from Belgium. Welcome, Christel.
Good afternoon.
Yeah, hi. Good
For
afternoon
you,
for
it's
you.
good morning.
Yes, it is. Yes, it is. Yes. And for our listeners, you may have seen Christel before. Christel is a mechanical professional engineer with 30 plus years of practical and application experience in helping pool clients with design and particularly with optimization of filtration systems and their control systems as well. So we've been working together for many years. I'm super happy that she could join me today because we're going to talk about a really important topic. And that topic is filtration. Christel, filtration. What do we think
Yes.
about when we talk about filtration? Why? Why do we even need to filter water? Like, what's that all about?
When you look to the water quality, you have to keep in mind that impurities brought in the swimming pool by your bathers, 50% is removed by oxidation, and it means in practical it is the chlorine and the acid dosing for to keep the pH in good shape. But the
Yeah.
other 50% that needs to be removed, and therefore we need a filter. So
Yeah.
50% of the impurance is removed by the filtration.
Yeah, and
And
that's an interesting statistic, right? Because here I think that everybody relies very heavily on the chlorine to keep the water safe. But like the filter obviously has to do a much bigger job than we think.
yes, yes. So and in that view, you can have several kinds of filtration types, but the most used here in our region is the multi-layer filtration with sand as support medium, and then the hydroantacide as really depth
As
filtration
the main
as
media.
the
And we're
main.
going to, right, that's perfect. And we're going to talk a little bit more about that in just a moment, but perhaps for our guests, our listeners, there are different types of filtration. So maybe in general terms, when we talk about filtration, there are four properties, I guess, Crystal, that we look for in filtration. And the first that everybody knows, I think, over here is physical filtration.
Yeah.
And maybe explain briefly to our guests what is physical filtration? What does that mean?
Physical filtration means that a lot of impurities what you see are getting stuck in your filter. Huh? And in practice, you have to take in count that what filter you have, sand or multi-layer, the thickness of the impurity is what is held on the filter is 20 micron.
Yeah. So 20 micron particles. So the size, so
Yeah.
imagine like a coffee filter, but obviously a little bit finer. It's like a 20 micron particle can be held back, but anything smaller than that would normally go
Will
through the
Yes,
filter
will go
when you,
through.
yeah. Now
Yeah,
there
and
are, yeah, go ahead. You wanted to finish your thought? Go ahead.
and that's something. For that reason, we need a support for your filter, because every impurities what is not taking out of the water by your filtration, your chlorine will react, because chlorine is a very reactive oxidation
Product. Yeah.
product. So, and
Yeah.
for that reason, it's important to support your filtration with anyhow a flocculant.
Yeah. Okay. So again, we'll circle back to getting into the weeds or a little bit more in depth on that topic a little bit later. So from a physical filtration perspective, there are a number of filters that have become, popular or being used or are emerging. Obviously, you've mentioned sand and multimedia, but there are other filters. So there are filters that use different kinds of media like perlite. They seem to have the capacity to remove smaller particles. So they have a good capacity for holding dirt as well as removing particles, the finer particles. So those would be things like perlite. I've also heard about glass beads. I've heard about, different kinds of filtration media. So maybe briefly, let's touch on, so the benefit of a perlite filtration system is, I guess, that, it takes up a much smaller footprint. It has the capacity to hold a lot of dirt, and it has the capacity to remove smaller particles, but there are also some challenges with those filtration systems. So maybe let's talk about that for a moment.
But I think one item you don't, it's important to take in mind. In a swimming pool, you have not only a mechanical filtration, it's also a big part, a biological filtration.
Okay, that's what I wanted to talk about.
Most important item to have good quality in your swimming pool. And for that reason, you need a filter medium that is capable to do some biologic filtration. And for us here in our region, a perlite filter is a very good mechanical filtration, but does not have any biological filtration, and that's a big disadvantage for that kind of filtration.
For that kind of filtration, yes. And so there would be different ways in which we would have to optimize a filtration system like that to also include a little bit of biological filtration, because that's not how that filter specifically works. And generally speaking, in North America, Christel, there has been a big move towards membranes and mechanical filtration, which is a good thing in some ways, but also a bad thing. Particularly, let's focus in on the biological aspect of filtration. Let's get to the root cause, chemically speaking, of why we need biological filtration. Can you talk about that?
Yeah, that is mainly because I think in Europe, Belgium and Holland are the two countries where a certain parameter is in the law that is saying us something about the biological filtration, and that it's urea parameter.
Yeah.
So and that parameter is saying something about the efficiency of your filtration, and can only be optimized by a biological kind of filter medium.
Yeah. So urea is what comes off of our skin when we void a little bit of urine in the pool. Yeah. It's sweat. It's everywhere, right? So it is the component. It's a nitrogen-based compound.
Yeah, it's a nitrogen-bound compound, and it's not removed by chlorine dosing. It's really moved by urease. It's the bacteria what is formed.
An enzyme,
enzyme what is formed in the filter medium, and that you need to remove the urea. And you have to think about it. The maximum parameter in Belgium and Holland is 2 milligrams a liter in the swimming pool.
Yeah. And that's a monthly measurement, right?
That's
part of the regular monthly measurement
that
the external laboratory has to do. And they have to verify that's the case. And so that's interesting. So urea removal is critical. What happens when we don't remove it and it builds up in the pool?
When you have a big amount of urea, you will get it's a source for the compound chlorine in your water. So the typical chlorine smell when your pH is also low, then you have problems. And the maximum combined chlorine in Belgium and in Holland is 0.6 milligrams a liter. It's very low. So it's really a question of having a good filtration together with your chlorine dosing. And that's both of those factors give you a good water quality when the pH is also about 7.3. Yes. That's very important.
Yeah, and we'll talk about pH a little bit more as well as we get into kind of the optimal filtration model. But urea, obviously, as you said, is kind of the root cause for chlorine smell in the pool. So your mono, di, and trichloramines come from urea, and the combination of that urea with the chlorine. So the higher the chlorine, the more potentially you're also going to create, and the less optimal your filtration, you're also going to not remove the urea. So it's going to make those problems worse.
For us here, it's very bad to have high levels of chlorine. It's a evil that you need to use, but a maximum, when you see in a swimming pool, the maximum amount of chlorine is in a pool is 1.5 milligrams a liter. That's not a lot. So and when your pH it's okay, then the oxidation strength of chlorine is enough to treat swimming pools where 2,000-3,000 people are in the swimming pool.
Yeah, I know. You have experience with that. Some very, very busy commercial pools that have thousands of people there on a daily basis. Like that's generally, of course, not been the philosophy over here, but that's mostly, I think, also to do with the fact that filtration is so suboptimal. So I think regulators are really worried about the risk that if you don't have, good process control where your pH is everywhere. And of course, the pH range is very, very wide here in for us, at least in this province of Ontario and in other provinces in Canada. Like there's, usually between 7.2 and 7.8. Well, that's a very large range, and that doesn't really get us to where we need to get to from a filtration perspective. And we'll talk about that, like I say, momentarily. So urea is the root cause. That's what we want to address in the first place. Obviously, we don't have the capacity for measuring urea. We'll occasionally send samples off to Labodurva, obviously in Belgium. And, we try and take a TOC reading, which is kind of somewhat related. Obviously, urea is a subset of the TOC, but it doesn't give us everything. No. And so anyhow, but, we do work with clients in that way. So maybe then we've talked about physical filtration and biological filtration. There's also the adsorption piece as well. And the chemically assisted piece you've touched on already. The chemically assisted filtration is using flocculation and proper pH control. So we're going to go and look at that. But maybe adsorption, let's talk about that for just a moment, because that, again, the 4 pillars of optimal filtration would hopefully have as many of those 4 as possible.
Yeah.
And, let's talk about adsorption. Why do we need adsorption as well?
That means that you have already a lot of impurities and organic matter what is adsorbed by the medium, and there is only one medium, and that is because the form, the way hydroantacide is made, and that makes it very good to have adsorption in the channels what is made by the production of hydroantacide, and that's a part of the adsorption, of the organic matters materials what you need.
No, maybe I'll just have a quick image here for people to take a quick look at, so that we can talk about, okay, what does that look like? I think that's it, right, Christel? That's what you're talking about, the channels here.
You have to when the hydroantacide is coming out of mines, like carbon, like steenkool.
Yeah, like coal.
Coal, and when that's coming out of the mines, it's a fixed coral
granule.
Yes,
yeah.
But by an extra treatment with high steam. They create the channels in such a grain. And when you compare that grain with active carbon grain, an active carbon grain has still more channels in that grain.
I see.
And it has is still more active as hydroantacide. And that makes it very good to have that part of filtration called
Adsorption, yeah. And so adsorption also is a way, I guess, to deal with existing disinfection byproducts potentially that are already in the water that you're trying to reduce. So that's something that, can be looked at, of course,
for
as
the
well.
Trihalomethanes.
Trihalomethane and some of those toxins that we want to remove for sure. So that's very interesting.
The active carbon is still better because of the high adsorption grade of active carbon. But for that reason, it works also in the other direction. We don't want active carbon in a filter in a swimming pool. Why? Because it's such a high adsorption rate that it will take all the chlorine out of the water, and that there will be a big chance for Legionella forming in the filtration medium.
Yeah, I know that Ludo has recommended that for clients who are having suboptimal filtration, adding a small amount on the top of a sand filter is helpful, but not a lot, right?
Not
and
a
the
lot.
small amount kind of gets washed out on a regular basis. So there is no risk for Legionella because it's not sitting in there all of the time.
No.
So you just refresh it and you add a few kilos every couple of weeks. After
every backwash, you put again a few kilos for a certain time, and you will see that your adsorption of, for example, trihalomethanes and bounded chlorine will go down.
Will go down. Yeah, exactly. So that's a useful way to do that. Okay. Well, maybe let's talk about, adsorption can be important or valuable, but you have to be mindful of some of its own challenges and limitations in that as well. The chemically assisted filtration is really what we're going to, chat about in the context of what's an optimal filtration look like as well. And so maybe now let's focus a little bit on sand filtration if we can, just because many people, many of our clients, I'll kind of pull up the sand slide. Many of our clients actually have sand filters. And so sand filters are still the most commonly used filter systems. But generally speaking, they are not using flocculant, and it also has its challenges as well. So maybe, Christel, can you walk us through what would be an optimal sand filtration system if that's what you have?
Yeah, when you need to work with a sand filtration, anyhow, you need more water to backwash it. That is, only water to backwash is not enough because of the weight of the sand. Your pump will never be enough to lift up your medium, because all the impurities in the medium needs to go to the drain. And for that reason, it's much cheaper to put a combination with water and air. And on that moment, you can leave your impurities direction drain. Because also a big disadvantage of your sand filtration is because the sand filtration is a cook filtration, and you need in practice much more backwash, because of the impurities will not go flush very quickly in your medium. It will only be the first 2-3 centimeters that will take out of impurities. And when you look to a filter diameter of 1 square meter and 1, 2, 3 centimeter, it will be already full, and then you need the backwash. So when you compare it, a backwash for a filter sand will be every 2-3 days, I think, to do it correctly, because otherwise your filter will be full and will not work efficiently anymore.
So let's, we have a slide here that talks a little bit about, the sand filter. And so what Christel is talking about for our guests, so we have a media in a sand filter, generally speaking, has to have a couple of layers of gravel at the bottom. Yes, Christel?
Yes.
Then the main layer is sand. What she's saying is, and many filters here, Christel, in Canada and in the US, I guess, are horizontal. And so the depth of the sand is even lower than it would be in a vertical filter. And so what you're saying is that the dirt holding capacity of a sand filter is significantly less compared to a multimedia filter or a multi-layer filter, as we call it. And so the cleaning really, without air-assisted backwash, it's almost impossible to clean the filter over the long term,
because
you're only taking the top layer off, or you're only cleaning what's on top of the filter, and that's it, because you can't lift the bed. And then the second part, go ahead.
And important is all impurities what stays in the filter will give you afterwards in your swimming pool again problems with combined chlorine, because all the impurities react with the chlorine in the filter and give you again combined chlorine and problems with the chlorine smell when your pH is not good. So for a good water quality, it's very, very important to do a good backwash on time, and certainly for sand filtration, I think 2-3 times a week.
Right. And that's really unusual here, right? So here, many people are backwashing every 2, 3, 4 weeks, because they've been told that they have to look at the pressure differential. Can you explain why that could be a problem, looking at a pressure differential only?
Yeah, I think you need to look to the flow, because sand filtration is a cook filtration. And like I told you already, the first 2-3 centimeters of your sand medium is only taking impurities of the water. And that is very quick full.
Saturated,
and therefore, saturated. And therefore you need to backwash much more than you compare it with an hydroantacide filter. And that's a depth filtration. And in a hydroantacide filter, your impurities will flush much easier on the whole depth of your 40 centimeters. So your amount of taking dirt in a multimedia filter, in a hydroantacide filter, it's much more higher than in the 2 centimeters of your sand filtration.
Yeah, and let's explain to our listeners, though, because they don't know what you mean by a cook filtration. What you mean is cookie, or meaning like a surface filtration, right?
It's a surface filtration.
You're creating like a cookie at the top.
On the top of the filter. And for medium, for multi-medium filtration, the hydroantacide, it's a depth filtration.
And it goes into all the crevices.
You have about 40 centimeters of hydroantacide in your filter, and you have much more amount of impurities taking in that 40 centimeters of 1 square meter than 2-3 centimeters of 1 square meter in a self-filtration. And in the practice, it means that multimedia filter is backwashed 2 times a week. And the sand filtration, I think, when you really want to do it good, 2-3 times a week.
Wow. Okay. Yeah, that's a big difference. But maybe then, Christel, why are people not seeing the pressure differential? Like, let's talk about that, because that's what we're being taught through some of the CPO training, or some of the other training. That's the standard explanation for a sand filter is, okay, you have to look at the pressure differential, and once that is significantly different, then you can backwash the filter. What could be some of the reasons that the pressure differential isn't actually showing?
The main reason when I see a sand filtration with the pressure display that they don't work.
They don't work properly.
That the pressure is really not good. I think in practice you need to in every swimming pool, I hear in our region, a flow meter is hanging on the wall, and you see when your flow is going down,
restricted.
Then you see that you need to do a backwash. I think that's your key
component.
Point.
Yes, a mechanical component. You have to have a proper flow meter.
Yes. And a lot of times your pressure meter is not working.
Yeah, I know. We've seen this too. And there are other reasons as well. For example, some people here do not even put they don't put gravel on the bottom anymore of the lateral system. So they just put sand, only sand in the filter.
Yeah, but you put gravel on the distribution system in the bottom to protect your distribution system, because otherwise it will be blocked and it will give problems. You really need to put your distribution system in the gravel, 3 to 5 millimeters of gravel.
Yeah. Yes, and yeah, we've explained that, because that may be something that they used to do, and then they say, oh, it's not necessary, but it is absolutely essential if you want to protect your laterals and have them last a good long time and do what they're supposed to do, right? So that's another important topic as well.
Yes.
So for our listeners, backwashing in sand filtration systems, if you don't have a flow meter, it's unlikely that your pressure differential isn't giving you is giving you the correct information or enough information, as well as you can have things called channeling. Christel, you want to talk about channeling? So what happens with channeling?
When you have channeling in your filter medium, that means that the filter is blocked because of impurities that stays in the filter for a certain long time, and the water will be very, very easy through the filter. So a good filter is working good when it takes a lot of time, that the water is going through all the layers, and when you have channeling in your filter, the water is very, very fast through your
filter. Takes the shortest route.
And you have no filtration anymore.
Yeah. And then I guess you wouldn't even be able to pick that up from the flow meter, because the flow meter would show that you have all kinds of flow.
Yeah.
But you have very poor filtration, and you've left it too late.
You see it in your water quality immediately.
You see it in your water quality. Yeah. So how do you remediate a filter that's really dirty and that hasn't really had the proper backwash? So maybe let's talk about those things. And what we've done here with multiple clients is where they even have a horizontal old model sand filter, but we have spent some time with them in looking at ways to optimize that filter. So let's talk about those steps, including flocculation. Well, actually, let's talk about pH first, why we need to have the pH and where it is. Let's talk about flocculation. Let's talk about air-assisted backwash. Let's talk about those three things. Explain why are those three things essential to get a suboptimal filter working a little bit better.
Mm-hmm. The first item is when you have the pH the set point needs to be about 7.3, because when the pH is higher, your flocculant will not work anymore. And because your flocculant is a metal, and when it's above the 7.4, the aluminium will not flock anymore and will not do her job in the filter, because all the small particles will be clitted together to a big particle and will stay flock, on your filter, a big flock.
Yeah, and obviously that brings our micron down to about 5 microns, right? It makes it significantly better. Yes.
Yeah, without flocculant, you have a filtration about 20 micron, and with flocculant, it's about 5 micron.
Yeah, that's excellent. And so first thing is pH. You have to get the pH in the optimal, and not just for filtration, also for good chlorine speciation, so that you have the right kind of chlorine to do its disinfectant work. So that you don't have to put in more, because if you get higher, anyway, there's lots of good reasons why, that optimal pH. And we say here for our clients between 7.25 and 7.35, or between 7.3 and 7.35 as the highest, so that at least, you have a very small window in which you can optimize that process, right? So, but continue. So you need first the pH, so then the flocculant, yes?
Yeah, and that's very important. And then a good backwash, because the flocculant is put on the filter, and it's an extra charge for the filter. But it's also important to do then the backwash, minimum 2 times a week, because the flocculant needs to be removed, and otherwise it will block your filter.
Yeah, and also it's going to end up potentially in the pool if your pH is not optimal, right? So we have seen this as well. So many people here will put a clarifier, they call it, in the pool. It's aluminum sulfate usually. They throw it in the pool, and then, they hope, well, with the right pH, it's going to all fall down to the bottom, and then they're going to vacuum it out. But we don't want that. We don't want any aluminum in the pool, because
when we have that here, I think they close the pool. It's forbidden to put it in the pool, because it's not good for the bathers.
No, it's not healthy. No, we need to keep this out of the pool water. We have to keep it on the filter at all times. Yeah, that's essential. So the air-assisted backwash, it makes a huge difference. Not only, obviously, Christel, as you mentioned, it lifts the bed, but it also saves water, like significant amount of water.
Yeah.
Because you're basically reducing the amount, right?
Yeah. It will say without air, it's not possible, because when you do a backwash with air and water, you first do a little bit water to backwash, then you bring the dirt to the top, and then with the air, you make your filter bed loose again. Every impurities can go up, and then with water again, you bring everything to the drain. You rinse it.
Yeah. Okay. So that's the principle. You do your first backwash just to get the dirt moving.
Yeah.
Then you get the air in to get everything to the top, and then you have your final. So you have water, air, and then water again.
Yeah. You have.
Go ahead.
And it's important that your air is big enough to use in your filter, because when you have a big filter, it's important that your blower is strong enough.
Is strong enough. Yeah. Now, because we work with a lot of horizontal filters, we've had to be careful as well, because obviously there isn't a lot of height at the top, and so we have to make sure that we get good turbulation of the sand, and that it's moving, and that it's actually turning over properly, without it coming out of the top and out of the filter, right? So that's kind of a balance that we have to have. But I think that's important as well.
Yeah.
Okay, so maybe then, so when you have a filter bed that's clogged up, can you remediate it? If you haven't done this, and you've been backwashing every 3 weeks or 4 weeks or whatever, and you're used to what you're used to.
You can try to use something to put a long stick in your filter, and to push it in your filter bed, but be careful with your distribution system, because you don't make damage that. But you can feel if your steel or your stick is going easy in your filter, and when you have some block then your filter is blocked, and you can maybe use a drain rat. How do you say it in English?
Yeah. I know what you mean.
A stick with water in it to try to open it, and when it's not good, you need
have to change the medium.
Yeah, you have to change your medium.
Okay. Yeah. Okay. So that's a good tip as well. Some ways that you can obviously verify to see if you can remediate it, yes or no. Okay, that's excellent. So maybe then let's talk about hydroanthracite for a moment. Obviously, we've already touched on the fact that it's a much more suitable media in a sense than compared to sand, because it has all of these channels. It has a significant amount of surface area, and the dirt holding capacity is much greater. A lot of people here, I guess, are concerned, Christel, that hydroanthracite is so different from sand filtration in terms of operations. And we try to tell them that it's actually very, very similar. And if you're used to a sand filter, then hydroanthracite is going to be no more difficult to operate. Can you talk about that a little bit? Like obviously how that works.
One item I didn't say, I think for sand filtration, the velocity in your filter may not succeed the 20 meters an hour for sand. And when you go to a multimedia filter with hydrogen, you can go to 30 meters an hour. So it means for same swimming pool, your filtration area for multimedia medium filter it's smaller than your sand medium, and that's something in the market is a lot of times a problem with the sand filtration. The velocity through the filter is much too high,
Yes.
and that's something very important and for the engineering to take in count.
Yeah, that is a really good call out. And, we've talked about it perhaps before, but the speed through the filter here, we talk about not meters per hour, but square feet anyway, but it's very similar. But what we really want to say is that faster is not better. So let's talk about that for a moment. Regulators here, they have stipulated that new pools need to have at least, I think it's 6 turnovers per day now. I know I spoke with Ludo about this as well at Laboderva, and he was talking about, okay, we want to do 4. 6 isn't necessarily better, but at least 4. But the consideration, I guess, even in our code, our building code, it doesn't really look at filter speed at all. So, for example, you could have a filter that's not been sized correctly, but it has, like a 10 turnovers per day, let's say, because it's going at a speed of 35, 40 meters an hour, a sand filter. And so, you may get a lot more turnovers, but you're actually not getting adequate filtration. And that's the big challenge, right? So it's about that filter speed, is that a requirement in the European regulations?
Not immediately, but our experience is that the sand filtration is coming is a lot of used in the drinking water market,
Yes.
and
Yeah.
there the maximum speed for an optimal sand filtration is 10 meters an hour.
Wow.
So
half the
yes,
speed.
it's half the speed. So for that reason, the multi-layer filtration with 30 meters an hour, and you have a much smaller filtration area when you use a multi-layer equipment and or filter medium, and you have the advantage that you have the absorption also. So every new swimming pool here in our Belgium, Holland, everyone is using the multi-layer hydroantacide. The sand filtration isn't used anymore because of the use of water and also
the sustainability
because of, yes,
and performance.
Yes, and performance, because you don't have a good absorption in that filter.
Yeah. So the key really is not speed through the filter in the context of, okay, more turnovers is better. It's all about having as slow as possible through the sand filter, rather than as quickly as possible, because if you run the water through that filter much more quickly, you also get channeling, right? You also don't have the proper filtration. Okay. So that's interesting. And I think that's an important piece of information. I've seen it in the Model Aquatic Health Code actually as well, where they talk about sand filtration being as slow as 10 meters an hour, and why it's important to to go slower through the filter. So there's a lot of people thinking very similarly over on this side of the pond, and hopefully that will start to reflect itself in the regulations, because I know in the German, the DIN standard that I've read, it talks about speeds, and it also talks about you have to use flocculant. It says that, it makes that very, very clear. So really, from an operational perspective, to go back to my original question, running a hydroanthracite filter is kind of easier than running a sand filter, because you have to backwash it less. It operates very similarly because it's still a multimedia. It still has media. The sand is the supportive media. The hydroanthracite is on the top. You backwash it less. It's actually about a third smaller in size, because you can go much faster through the filter and still get really good filtration, because it has the dirt holding capacity that that's not possible for a sand filter in the same way as well.
The only thing where you need to think about is that you give every filter sand and hydroantacide a good air relief system, because air in the filter can be very unpleasant.
Yes. Yeah. Explain.
When you have air in the filter, with a multi-layer filter, your water can be black in a few minutes. So when
Yes.
the air is in the filter and gives it gives all the dirt will from the filter will come in your swimming pool. So you need to have an automatic air
Air
release
release
system.
valve. Yeah.
Or yes, on your filters. Very
Okay.
important
And
when you
you would
use.
also recommend that for your sand filter?
Yes, always.
Okay.
Always use an air relief valve.
Okay. Very interesting. So maybe then, what are some of the common mistakes? Is there anything that we've missed in our conversation of what people are not mindful of, or what are the things that you find the most commonly, I guess, when you're looking at people whose filtration
When
systems?
when I look to the multi-layer multi medium filter, the most thing I see as a mistake in your installation is that the circulation pump is too small to give double speed to
Backwash.
backwash your multi-layer filter, because it's a depth filtration. So it's important that you have a fluidization of minimum 25 centimeters. And when
Yeah.
your pump is not strong enough to do that, all your impurities will stay in your filter and will give you problems in a
Yeah.
certain time.
Yeah, that's. I'm really glad you mentioned those two things. So one is that because the hydroanthracite is such a light media, it actually lifts up quite easily if you
Yeah.
have a good pump. So
Yes.
it has to, and that's why when you design a multi-layer filter or multimedia filter, you need to have at least 25 centimeters, what we call freeboard or space above the top of the media, so that
Yeah.
when you backwash it, it can go up and it can do its
Yes.
cleaning action, right?
Otherwise, you bring the hydroantacide to the drain, and that's a little bit stupid. That it's not
Yeah.
good.
No, because you're
Your
wasting media and
your
so on and so
filter
forth.
needs to be high enough.
It needs to be tall enough. Yeah,
Yeah.
exactly. And then the other point that you made was, so when you're designing a filter system with multimedia, you also have to make sure that your pump and your pump curve actually can meet the requirements of the normal speed through the filter, as well as the backwash speed, which is significantly higher than the
Yeah.
normal speed through the filter. So it has the capacity to clean it properly, because otherwise you're not actually going to lift that bed
No.
and clean all of
And
those.
all the
Yeah,
impurity stays in your multimedia filter, and you will get afterwards in your swimming pool problems with combined chlorine.
yeah. Okay, yeah, that's excellent. That's good to know, and that's important as well. Obviously, as part of the engineering requirements, so that when you're doing that, you have to look at those aspects very carefully as well. Okay, maybe Kistel, mechanically speaking, talk about how many valves and how that works, because that's not common here as well. So just for a moment, what does a good filter need to have in terms of valves?
Normally you need
Yes,
five valves.
five. Yeah, explain
Yes.
why five.
One, two for the to the in coming to let the water in the filter, and the other one to get it out of the filter. Then you have a valve, that's the filtration side. When you enter the filter at the bottom of your filter, there's also to do the backwash again, a valve, and then that water is not going to the swimming pool, that is going to the drain. You need
Yeah,
again a valve, and
yeah,
then the first filtration after your backwash is very important. We don't bring that water to the swimming pool, because on that moment you will have light gray water, and that's still dirt, because you are putting up your filter medium again to each other. that first water we bring to the drain about 30 seconds, and for that reason you need an extra valve. So
The
in
fifth
total
valve. Yeah.
you have 5 valves in your
Yeah.
system.
And that's called a rinse at the end. And it's really
The
helpful because you
first filtrate, yes.
Can we talk about that for a moment? Because we have clients who've inherited a poorly designed filter system that doesn't have 5 valves and, in fact, have no capacity for rinse at all. So how would you solve that problem when those folks are backwashing?
Yeah, it's important. It's very difficult because when you are backwashing, you lift your filter medium up, eh? And when you are bringing the water again above and going down, your water your filter medium is pressed together, and because of that pressing together, when that water is going to the swimming pool, the first few minutes it can be a little bit gray,
Cloudy,
so
yeah.
not cloudy. So and for that reason, normally you need to have that water to bring to the drain. So without first filtration, it's very difficult. Then you have to take account that that first water is not clean like you want.
Yeah. So so there's no real solution for that problem other than to maybe backwash a little bit more often. Maybe
No, because
no.
that first water, then maybe the only thing what you can do is when you do the filtration, that you do the first few 30 seconds not to the swimming pool, but still to the drain.
Ah, okay. I see. So you can put the filter back in filter mode, but not to the pool, but to the drain.
Yeah, a few, but you lose that water, and
I know.
water costs money, and it's a little
I
bit
know.
stupid.
So really the way to do this is to get the filtration system upgraded to have 5 valves.
Yes.
Yeah. Because that would pay for itself, I would think, relatively quickly because of the water you would be saving in not having to send it. Having to. I understand. Okay.
You have always some water what is going to the drain, but when you can keep it short, it's okay. Yeah.
Yeah, keep it short rather than yes. Okay, that's really helpful as well, I think. Okay, is there anything else that we haven't touched? I think you've given an excellent overview for our listeners in terms of how to maintain and optimize their filtration system, as well as if you're looking to potentially change your filtration system, what some of the options are. I know we didn't talk a lot about some of the more modern physical filtration systems that do an outstanding job on the physical filtration, the mechanical filtration, other than to say it's possible if you have a perlite system, let's say, to also optimize that. But you're going to have to find a way to do this by adding some media that also allows some of the biological filtration as well. And so that we can talk about. If there's interest in that, you can reach out to Synicotech and we can talk about that.
When you have, for example, a medium with glass, you can always remove some glass out of the filter and put a hydroxide on it. But it's a little bit stupid because you need to do the cost to remove everything. And for a good quality, I think it's better to do the whole cost and remove everything than do half.
And just a bit. No, I understand that. I understand that. And I think with glass filters, that's possible, right? Glass media, that's definitely possible. It's a little bit different when you have a perlite system. You're going to need to, because usually those systems are built to last a long time. So they will need some remediation with adding potentially some activated carbon or
activated carbon to have your absorption,
some absorption,
in your filtration,
and dealing with the organic fallout really is what you're trying to contend with. Okay, that's excellent. Is there anything we've missed, Christel, or any final bits of advice? I think this has been excellent, but anything else that we haven't touched on?
I think we talked about a lot of things.
Yeah, I think so too. I think, hopefully to our listeners, this was a helpful conversation. It's certainly been great working together with Christel all of these years because we have adopted many best practices. We both have the same mentor, Christel, so that's, that helps us definitely do things correctly. There's a lot of experience, obviously, in seeing, something run so much better, right? When a filter runs well, it
Yes.
has such a tremendous benefit on the rest of the process as
Yeah.
well.
Yeah.
For the operator, it's a lot less hassle. There's many, many ways in which that benefits the whole of the pool envelope, not just the filtration system, but actually everything else as well.
Yeah.
And so I think, it's great to have some focus on this. So I want to thank you, Christel, for making time for me
It was a
today. I really
pleasure.
appreciate it. We think that it's a great topic. And so thank you. I hope you have a wonderful rest of your day. And audience, also thank you
Okay.
for listening to us today. You can listen to this episode and many others by subscribing to our YouTube channel or connecting with us on Apple Podcasts or Spotify. If you have questions about this episode for Kistel or myself, or Scott, and any future topics, please, you can email us at mywatertalks@sanicotech.com. From Scott, who can be with us today, and myself, and from Kistel, thank you all and have an excellent rest of your day.